friends. So today we're going to start our second tutorial on machine learning from the machine learning playlist. So in the first tutorial, I tried to explain what exactly is machine learning and how it is different from a normal traditional software. And I also discussed something like what are the challenges in machine learning. So today I will discuss in detail about those challenges, and also I will try to make you understand the different types of machine learning. So in the first tutorial we understand what is machine learning. In this tutorial we will understand what are the different types of machine learning. Okay, so the first thing that we will cover is different types of machine learning. Again, guys, just pardon my handwriting. Different types of machine learning. Then we will complete the discussion, the last discussion that we had on what are the challenges of machine learning. That we read as ML. And third, I will give you a brief description on the basic statistics. So this minimum knowledge of this statistics is required to undergo further training on different machine learning algorithms. So today's class will just focus on few of the statistics. For example, what is mean, what is mode, what is median, what is variance, what is standard deviation, right? So these are the concepts. So this particular statistics part, most of you have already studied in your class 10 or class 12, if I am not wrong. So we'll just revise those concepts. Okay, so the whole tutorial will comprise of only these three sections today. Okay, so let's start. So what are the different types of machine learning? So we know what machine learning is. Now we want to know, okay, how we can classify them. So machine learning can be broadly classified into three categories. Okay, so classified into three categories mainly. Okay, mainly in three categories. One is supervised machine learning. One is supervised machine learning. The other one is unsupervised machine learning. Unsupervised machine learning. The third category is semi-supervised machine learning. Semi-supervised machine learning. And then there is also one more machine learning, which is called as reinforcement. Reinforcement machine learning. So in our course, we will be basically working with these two. Okay, this is a completely different, you can say, beast altogether. But I will describe each of them what actually they are. Okay, but our course will mainly focus on semi-supervised and unsupervised. Semi-supervised, once you know what is supervised and what is unsupervised, and when you will learn how to deal with this particular machine learning algorithms and models, you will ultimately be able to know how to deal with semi-supervised machine learning. But this is a completely different topic altogether. And I will give you a brief idea about what is reinforcement machine learning, right? So instead of 3, I guess it is 4. Sorry, it is 4 categories. Now, okay, so we know the classifications. We know, okay, supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement machine learning. These are the terms. What actually they are, that is important to understand. What is supervised machine learning, right? So let's take this topics one by one. Okay. So I'm going to separate screen. Okay. You can obviously come back to the screen for reference. Okay. So let's understand what is supervised machine learning. Supervised machine learning. So any machine learning that we do with human supervision is called supervised machine learning. Okay. So which require human supervision. Now, what does it mean? What do you mean when you say human supervision? Because in my first tutorial, I said that machine learning can do things which human can't. So then where from this human supervision came into picture? So human supervision is nothing but in supervised machine learning, what happens is, so there is a so in the first tutorial, I discussed about input features, and also there are a few terminologies which we will understand today. Okay. After that only we will start the supervised machine learning thing. So the first thing is there will be data, right? There will be data. Now data is nothing but it will be comprised of rows and columns. Majorly, I mean rows and columns. So it will be like let's say age. Okay, let me give an example of how the data will look like. Age. Okay, then there can be gender. This is one column, this is another column. Then there can be income, and then there can be expenditure. Let's say we have these 4 columns, and then we have different data around it. So let's say 24, 36, 38, 42, 58. Let's say this is female, 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 male, male. Let's say income. Let's say if we consider in terms of dollars, so let's say 50,000. It may be 65,000. It can be 43,000. And this is monthly. This is monthly income. Okay. It can be 36,000. It can be 55,000. And then expenditure, this also will be monthly expenditure. It may be roughly around 26,000. It can be around, let's say, 34,000. It can be around 27,000. This can be 13,000. This can be 25,000. Okay, so this is, let's say this is a data set. This is a data set. So data basically comprised of rows and columns, right? These are the columns and these are the rows. These are the rows. Okay. So this is the data. Okay. So now in this data, let's say this, okay, so let's say age, gender, and income are input features. So input features are age, gender, and income. And expenditure is an output feature. Expenditure is an output feature. What does it mean? It means based on their age, based on their income, expenditure is expenditure of the particular month for this many people are given to you. Okay, so next time when there will be any new data, you need to predict the expenditure. Okay, for this many features. So let's say a new data like age is 28 and it's a male. Income may be around let's say 39,000. So what will be the expenditure for the month? This is something that we need to predict. Okay, so here we train this particular data set. We train this particular data set. And then based on our training, whenever a new data comes, we need to predict the output. Okay, so we need to predict the expenditure. In this case, expenditure is the output variable. So this is how we define input features and output features. Now here, see one interesting thing to see here is these input features are also called as independent features. Independent features. What does it mean? It means that the value of this features are not dependent on anything. Right? 24 age is not dependent on anyone. Female, she is a female, undependent. 50,000 she earns per month, 50,000, not dependent on anything. Whereas the expenditure is a dependent feature because expenditure will depend directly on the income, right? And also it will depend on the age because if you are, let's say, 10 years old, or let's say if you're not earning, your expenditure will be less. If you're earning and you're in the 30s, your expenditure will be more. Then you get married, your expenditure will increase. So expenditure will definitely be dependent on these many features. So the output feature is also called as dependent feature. So these terms I will be frequently using in my forthcoming videos, and that is the reason I'm trying to explain all of this now. And you should remember this. Okay, so the input features are also called independent features, and the output feature is also known as dependent features or target feature. Target variable also we can say it. Now why target variable? Because this is the target we need to find out, right? So this is the output. We need to predict the output. So this is the target, right? So input and output. So this is a small terminology check for you guys. Okay, let me run this, guys, so that I can start explaining you what actually is supervised machine learning. Give me a moment. So supervised machine learning, in supervised machine learning, you will know the output variable. So the past data, what we do in machine learning is we understand the past data, right? Whatever data we have in hand, understand the data in hand. So let's say this is the data that we have in hand. Okay, this is the data we have in hand, right? So, and as we know, these are all the input features, and this is the output feature. And this is something that we need to predict. Whenever any new data comes, this input features will be given to us. We need to predict the output feature. So understanding the data, training that data, or you can say finding out the relationship in the data will happen on these past data. And this past data has an output feature present in it. So whatever will be the input features, there will be always an output with respect to that input feature. Right? So let me repeat again. Whatever may be the input, there will be an output for this input features. Right? So this is calculated, this is studied, or this has been collected under human supervision, right? Someone in the company or someone in the sales or in the HR department will have some similar kind of a data. They have collected the data, right? So this data, that's the reason we say that supervised machine learning is something that which require human supervision, meaning we can predict something only if we have a data in hand which also have the output corresponding to the inputs. Only then we will be able to predict anything which has its input. So this is supervised machine learning. We are learning something based on few data that we have in hand, which has an output. That this is very important, which has an output. If data has an output already, that will that will come under supervised machine learning. Because here in supervised machine learning, the very word supervised, it means that the past data that we're going to study already have the output. Past data have the output. So our job in machine learning will be to find out the relationship between these inputs and the output. That will be our job, so that if any new input comes, we'll be easily able to predict the output. And that is called supervised machine learning. Okay. So to wrap up everything, I meant to summarize everything. What happens in supervised machine learning? Supervised machine learning, the output feature is given in the past data. So we have to find out the relationship between the input features and the output features, so that whenever any new data comes, this is a new data. Whenever any new data comes with the input features, we will be easily able to predict the output. And this is called supervised machine learning. Okay. Now let me give you some examples of supervised machine learning. Okay. So let me rub this portion. Move this portion. Guys, so the thing is, if you find any problem in understanding, please let me know so that I can improve, because I'm also starting this from the very beginning. I want each and every one of you to know exactly what I'm trying to convey, so that it will help you in understanding all the concepts. Because my goal, as I said in my first tutorial, is to explain each and everything in machine learning. Okay, so far I know. I will try to explain everything. But if you have something in your mind, just let me know so that I can work on it. Okay, so now let me give you some examples of supervised machine learning. So we know that the output will be given, right? Output is given, and then we need to predict the output. for the new data, right? This is something we know. Examples may be sales prediction. Sales prediction in a company. It can be an example of supervised machine learning. So what will happen? We will get a past data of different sales history and the input features also, which basically are the factors driving that sales for the company, right? So let's say we want to predict the sales for the for 2022, and we have in hand data of 10 years till date, till today. Similar sets of data will be there where we'll have the sales as an output variable, and there will be some input features. Okay, so this can be one example. Second can be, let's say we want to find out the house price of any locality. Locality will be given. It can be anywhere around the city, and it can be done by the various companies who are into, land acquisition or state services, etc. So there may be many customers who want to know the price of a particular house in a locality, right? So there will be similar data sets that will be available to us. There will be input features. Output feature here in this case will be the house price. Input features can be number of rooms, number of gardens, number of bedrooms. That can be anything, right? So based on this particular number square feet area for that particular house, so based on this particular features, output will have a particular value. Output is dependent on these features, right? So house price can be one more example. Third can be to predict, let's say predict whether tomorrow it will rain or not. Okay, so it can be third example. So then again, there will be input features, there will be output features, right? So based on the forecast, we'll predict whether there will be rain or not. And this is also some kind of supervised machine learning. So again, this supervised machine learning are classified into two classes. I will come to that. But let me first of all give you the examples. Okay. Fourth, and there are numerous examples, and it's not limited to only this few. Fourth may be predict whether a person has diabetes, or let's say has let's say diabetes. Okay, so there will be again data with all the input features, right? And there will be an output feature whether he or she has a diabetes or not, right? There can be food quality, whether he's sleeping properly or not, what is the glucose level, and all those informations will be our input features based on what the output will be predicted. So these are the few examples that we have in machine learning, where the past data has already the output with respect to all the inputs, and the new data that will come in will have only the inputs, and we need to predict the output. In this example, sales. In this example, the house price. In this example, to predict whether it will rain or not, yes or no. Here also, to predict whether the person has diabetes or not, yes or no. Right. So now let me quickly tell you the different types of machine learning. Okay, so let me go to a separate screen, maybe. Okay, so types of supervised machine learning. So there are two types. One is a regression. One is classification. So these are the two types of supervised machine learning. Whereas regression deals with numerical data in the output feature. Now you know, right, what is output, what is input. So it will be easier for you to understand. Numerical data means numbers. It can be a whole number, it can be a fraction, anything. So any numerical data, if it's present in the output, it means it's a case of a regression problem. Classification problem, as a name suggests, like classifying, meaning there will be classes, right? There will be classes. So it can be 2 class, it can be 3 class, it can be any multi-class, right? So there are like binary classification, right? Classification, or there can be multi-class classification, multi-class classification. Meaning there can be, when I say class, what do you mean by class? Let's say yes or no. It can be 2 classes, right? Then there can be classes like high, low, medium. This is case of multi-class classification, multiple classes. Here we have binary, 2 classes. So any problem statement which has this as the output, right? This is the output, are categorized as supervised machine learning, and it's a classification problem. So in the previous screen, I was talking about this 2 examples, right? Predict whether a person has diabetes or not, or predict whether tomorrow it will rain or not, right? So what actually it means? It means the data sets will be, let's say I take the case of a diabetes. So glucose level, one is this feature, sleeping hours, maybe this is another feature, and there'll be other input features, and then diabetes, this is the output feature. So these are all input features, these are all input features, and this is the output feature. And the data can be, the glucose level can be 114, 125, 110, etc., etc. Sleeping hours maybe 8 hours, 5 hours, 3 hours, etc., etc. Diabetes, yes or no? It can be no, yes, yes, and so on. So if you see this kind of a problem or this kind of a data, then you can easily know that first of all, it's a supervised machine learning because output is given. And secondly, it's a classification problem because it deals with 2 classes, right? The data is not numeric. In this case, if you see this example, it's a numeric data. These are numeric data, right? These are numeric data, right? So here, this is not numeric. So these are classes basically, and it can be also written as 0 or 1. So yes can be denoted as 1, no can be denoted as 0. So it can be like 0, 1, 1, etc., etc. So if you see this kind of data, you know that this is a case of a classification, and since the output is given, so it's a supervised machine learning problem statement. Okay, so this is all about supervised machine learning. Right now, let me discuss about unsupervised machine learning. So we understood supervised machine learning. Okay, we defined the data set, how actually the data set will look like. We came to know about the input features. What are input features? What are output features? What are the terms used for them? Like input features are also known as independent features. Output feature is also known as dependent features or target variable. Ultimately, these are all variables, but you can name it as features or variables, but input features or input variables, target feature or target variable. Okay. In the case of classification, these are also known as labels. These are also known as labels. Category 1, category 2. In multi-classes, there can be category 1, 2, 3, something like that. And ultimately, we knew regression. What is a regression problem statement? What is a classification problem statement? Regression problem statement will have numeric data in the output feature. Classification will have labels. These are called as labels. Yes or no, 0 or 1, 1, 2, 3, high, medium, low. Right? These are like binary or multi-class classification. In binary classification, basically, we'll deal with two variables, two classes, two labels. And in multi-class classification, there can be more than two labels, or more than two classes. Classes or labels are the same thing. So this was all about supervised machine learning. Now let's try to understand what is unsupervised machine learning. What is unsupervised machine learning? So unsupervised machine learning is something that deals with only input features. Okay, in the data, we will have only input features. There will be no output feature. No output feature. Now you may raise a question. Okay, if there is no output, then what we will predict, right? Because in the previous discussions, we have seen that based on the input, we are trying to predict something. We are trying to predict the output. But here I am saying that unsupervised machine learning has only input features. So if there is only input features, there is no output feature, then what's the use? Where do we use it? Or what's the purpose of having it, right? What we will predict? So so many questions, right? So in this case, let me explain. Unsupervised machine learning basically helps us to segment our data into different groups. That's the only job of unsupervised machine learning. It will help you to segment the data. So we have input features. Now in this input features, there may be, okay, let me give you an example. Okay, let's say we want to make, or okay, let's say we want to, let's say we have a mall. Okay, in a mall there are clothing shops. Right, there are clothing shops. There are other shops as well, but our focus is clothing shops. Now the owner of the clothing shops wants to understand what actually wants to understand the behavior of the customers. Okay, based on it, he or she will make some changes in their shops to increase the sales. Ultimately, the end goal is what? Increase sales, increase something, right? Increase. There should be a profit. There should be a profit to every company. So the owner of this particular shop wants to understand what is the behavior of the customers, what they are buying, how much they are investing, right? How much they're investing. So which particular section they are more interested in. Customers are interested in, because there may be many sections. There may be kids sections, there can be women's section, there can be men's sections, right? So as an owner, I want to know, because based on it, I will increase or decrease my quantities, right? Let's say there is a huge demand in the kids section, so I will include more and more new fancy stuffs in the kids section so that I can increase my revenue and can increase my profit, right? So it's very important for the owners to understand the behavior of the customers. So in this case, you see, you will only have the inputs. You will not have the output feature. Input 1, input 2, input 3, input 4, and so on. What are the inputs basically? These are the customers. Customer 1, maybe customer 2, maybe customer 3, etc. And what they are buying. Okay, what they are buying and all. So ultimately, what will happen if you try to plot them in a graph? Let's say this is X. This is the things they are buying, let's say. Okay, so things customers are buying and this is the sales, let's say, in the y-axis. Okay, so now based on this, there may be sales somewhere here, there can be sales somewhere here. This is one category of let's say there it's a kids section or something. Okay, let's assume. Now let's say there is sales over here. Yeah. So this is how it is distributed, right? This is the things they're buying. So let's say these are kids garments. These are women's. These are men's. So it is plotted in this way, right? So here we only have the inputs, right? We don't know what to predict. Neither we want to know what to predict. We have a different problem statement over here. We want to segment our users, right? So with the help of this graph, we can easily segment, right? This is one section. This is another section of users. And this is another section of users. So in the men's section, you can see there are only 3. Here you see kids have more, right? Women has lesser items bought than the kids sections. So the customer knows, okay, so the kids sections, I need to invest more because there is more sales in the kids section, right? So ultimately what we're doing here is customer segmentation. Customer segmentation based on their needs, based on their buyings, we are segmenting them into different groups. Okay, so this is customer segmentation. It's a very important concept. How we do customer segmentation, what actually is customer segmentation. So basically we are grouping them into different categories, you can say. Okay, grouping them into different categories based on their inputs, So based on their buying capabilities, based on their buying interests, we are categorizing them in different groups, right? Now this graph may change for different X values, right? So there, if we say, let's say they wanted, let's say it's a grocery shop instead of a clothing shop, it's a grocery shop. In the grocery shop, there may be various items of food items, right? So then this X input variable will differ. So then buying, let's say the customers in the X-axis, we have customers who are buying. So then we know that, okay, let's say this is vegetables. This group of people are more interested in buying non-veg items. This particular group of people are only interested in soft drinks. So as an owner, by seeing this particular graph, I can easily say in which area I need to invest more, right? So this may be another use case. So depending on the input variable, plot will be different, but ultimately end goal is the same. We want to segment our customers. So this is all about unsupervised machine learning, and it's very important. It's very important to know because this is also one of the use cases. This is also one of the demands in the market, right? So this is all about unsupervised machine learning. And this is a very small gist about unsupervised machine learning. Again, in unsupervised machine learning, there are various concepts which we will cover in the forthcoming tutorials, right? So just for now, just keep in mind that in unsupervised machine learning, we have only input features. We don't have any output features. And there, basically, we want to segment our data in different groups. That's the whole purpose of unsupervised machine learning. Okay, so now we have covered what is unsupervised machine learning. Now, the other one is semi-supervised machine learning. So let's say the third one, I change the color. Okay. The third one is semi-supervised machine learning. So semi-supervised machine learning is a mixture of supervised and unsupervised machine learning. What does it mean? It means that majority of the data set will be unsupervised. And also there will be some sort of supervision in that particular data set. Okay. Now you will be more clear if I give an example. Let's say Google Photo Service is one classic example of semi-supervised machine learning. What happens is, let's say we take pictures of 5 different people. Okay, and we take 10 photos. Okay, now this service will be able to identify, let's say 5 people are like A, B, C, D, E, and F. Oh, sorry, not F. Okay, so there are like 5 people, A, B, C, D. Okay, so the Google Photo Service will be easily identify that this particular guy, let's say A, in these 10 photos, he was present in 3 of them. A is present in 3 of them. B is present in 5 of them. C is present in 1 of them. Like that, it will be able to identify. So what actually we are doing here? We are doing unsupervised machine learning, right? What we're doing, we are grouping. We are grouping our customers, in this case, grouping the people, right? A is arriving in 3 of the photos out of 10. B is arriving in 5 of them. C is arriving 1 of them, right? So we are grouping them as we saw in our previous discussion. One group, another group, another group, right? So this is unsupervised machine learning. So this is the unsupervised part of the Google service. Now let's say we label this particular guy's A, let's say his name is Rob. B, his name is Mary. C, its name is Bilal. D, its name is Ravi. And E, its name is, let's say, John. Now, when you label this particular people, now you can easily in the photo, if there is one photo, let's say, and there are like these guys present, so you can easily mark them. This is Rob, this is John, and this is Mary. You can easily mark them, right? You have seen this in Facebook as well. When we click a photo and we paste it, and if in that particular photo your friends are there, then they will easily mark their names, right? And for the unknown, they will not mark it because they don't know. So this is the supervised part of it, where we are labeling the names for the different people. So this is semi-supervised machine learning, half supervised, half unsupervised. First of all, what we did, we grouped the people. So we know that this particular guy has appeared in 3 of the photos. This guy has appeared in 5 of the photos. Next, what we do, we just label the guys. So ultimately, the end photo that we have, we know that this is Rob, or this is John, and this is Mary. This is one classic example of semi-supervised machine learning. Okay, now let me come to reinforcement machine learning. So reinforcement machine learning. Just pardon my language, guys. I know my language is sorry, my handwriting is not that good. So reinforcement machine learning is completely different story. Here, the machine learns by committing mistakes. We can say that. Our machine learns from its previous, let's say we say in this way, not mistakes. We say by previous experience. Okay, so there is a concept of points or rewards in this machine learning. Machines in this case are called as agents, and they set some policies. Okay, so based on these policies, they will make some action, and based on the actions, we will either give them positive rewards or negative rewards. And at the end of the day, the machine will try to earn as many positive rewards as it can. So if it gets a negative reward, it will immediately go back, retry again, try to achieve the positive reward. That's the whole job of that machine learning. And this is how reinforcement machine learning works. Now it is being used in building autonomous cars as well. and it's quite hot in the market these days. Now, one example, I will just give you one example. Okay, because this is the topic that we will not cover. This will be out of scope for this particular machine learning course. Maybe in future, I will include this reinforcement machine learning as well. But let me give you a very small example. Let's say this is a robot. Pardon my diagram, right? Let's say this is a robot. Let's say we have let's say we have a tap. Okay, this is water, and let's say we have a water can. Okay, maybe water can, water tank, whichever you fill. Okay, and there is some socket that is there, some plug, electrical appliance. It is on fire. So as a robot, and there are various points I have assigned. Let's say if he's able to, stop, extinguish the fire, it will be awarded 100 points. So this is the job. So what it will try to do, it will try to get this 100 points as soon as possible, and then immediately it will move to its next job, which I will give, right? So maybe that job may have higher price. So at the end of the day, as I said, it will try to collect as many points as it wants. So if you see this particular, you can say like it's kind of a bounty hunter, and not exactly bounty hunter, but think like that. There is an award, and this particular guy wants to win this particular award by hook or by crook. Okay, so let's say it's trying for the first time. It went near the fire directly. There is a negative 50 points associated if it goes directly without the water. Let's say it went directly. In that case, it automatically is awarded with minus 50 points. Then it knows, oh, this is negative reward. I need to think of some other policies. So he will change his policy. He will see. So he will first observe. Okay. So the first task will be to observe what is the environment next to him. So let's say the first move he made, he is awarded minus 50 points. So his job is to overcome these negative points and to earn as many positive points as once. So when he observes, he see there is a water somewhere here. So it will first of all go there, take the water tank, and then it will make its move here. So there will be 100 points awarded to him. He will pour the water, he will extinguish the fire, and the job is done. So in this way, it learned. So it made a mistake for the first time. Then it did the right choice, and then it is awarded. So the whole system of reinforcement machine learning is this reward points and having learning by its previous experience. Maybe instead of going for the first time directly near the fire, it have observed and it was intelligent enough to go and take the water first. It may happen also, but this will happen only if it has previous experiences. If in previous scenarios, if it has faced some kind of similar issues, then it will go directly, take the water, then extinguish the fire. So this is how reinforcement machine learning works. Okay, so this is all about reinforcement machine learning. So now we know what are the different types of machine learning, right? And now let me speak about the challenges of machine learning. Let me take this particular page only. So now we have discussed the different types of machine learning. Now, what are the challenges? The challenges I have already covered in my previous class, right? A few of them. So there are, in terms of interview, if someone asks you, okay, tell me the challenges that we face in machine learning. So let me write it down for you. One of the challenges is insufficient data. Our whole concept of machine learning is to deal with data. If we do not have sufficient amount of data, then the models that we will build will be inefficient to predict anything. So data should be in sufficient amount so that more and more data goes in the training so that the model is trained properly and it will be able to predict properly. Right? So training must happen on sufficient amount of data. So when we have a problem statement, we must have a training data and the data should be sufficient enough to solve the problem. The second is non-representative of the training data. Now, what does it mean? It means that if the data that we have in hand is not exactly the data that can solve our problem statement, then no matter how much good our model is, it's useless because it is not actually representing our problem statement. It's not solving the problem statement. Maybe the data that we have is completely of different nature. Right? It's not a true representation of the problem statement we have in hand. It might happen. So in that case, we have built the model, though its accuracy is high, but actually the problem is different and it is not solving that problem. So this is also one of the challenge, non-representative of the training data. Third is poor quality of the data. Poor quality of the data. I in the previous lecture, in the previous tutorial, you might have heard me saying about outliers, right? Outliers or null values. There may be data that is given to us, which is sufficient and which is a true representation of the problem statement that we are dealing with, but the data don't have a very good the data that we have do not have a proper quality. Let's say we have lots of null values in the data, or there are huge outliers present in the data. I will discuss what actually are outliers. So for now, we just understand the outliers are data which are completely different from the rest. Okay, so let's say we have data like 1, 3, 6, and 8, and then we have data like 1,000. So this is an outlier in this particular data set because these are the numbers which are less than 10, and all of a sudden we have a number which is like more than 10, thrice almost than 10. So this is an outlier in this particular data set. So if we have this kind of problems in the data, or we have, let's say, null values, let's say we have one variable age, which is very crucial, and majority of the values are null. So how we will use this variable? We cannot use this variable, right? And it will help us, it will not help us in any way to predict what exactly will be our prediction, right? It will not help in the prediction ultimately if we have so many null values. And imagine we have different features and all of them have null values. So in this case, what actually we will predict, because the training will be inefficient, right? Because of this problem. So poor quality data is one of the main challenges of machine learning. And then there is something also called as, let me just rub this, guys. Let me rub this portion. This I am discussing from interview perspective. Let's say someone asks you in an interview, what are the main challenges so that you will be able to answer them. Okay, so the fourth one is overfitting. Now I will also make you understand what is overfitting, what is underfitting, what is optimized model in my forthcoming videos. But for now, just understand this. Overfitting is something that happens with training data. Okay, what actually it means? It's like we have trained the model in such a way that it only understands the training data only. Whenever you give any new test data, it will not be able to predict properly. Okay, meaning that it hasn't understood the hidden relationship between the data, between the input and the output variable. It has not understood the hidden logic. It has just fed the data. For example, to give you an example, let's say we want to train the model to learn about addition. Okay, giving examples is very easy way to make you understand, right? So whenever you will learn, you will remember these examples and it will be easier for you. Okay, so a very simple example. Let's say I want to build a model which predicts addition. Okay, so in training, I used variables like 2 plus 3, 5, 3 plus 3, 6, 4 plus 2, 6, 1 plus 5 is equal to 6. This is something that I use in the training data. When I say overfitting, it means that it has learned only to add 2 and 3, 3 and 3, 4 and 2, 1 and 5. It has learned it. So in the test or in the test data, if in the prediction, if you give what is 2 plus 3, it will very well be able to predict it as 5. But if you give something like what is 5 plus 11 or 5 plus 7, it will give you a wrong prediction. That means the data has learned everything in the training data by heart. It didn't try to understand the hidden logic, how actually addition works. It didn't understood. It only understood the training data. And it fails in testing data. This is something which is called as overfitting. Now I will explain more for overfitting in my forthcoming videos. But for now, this is just enough for you to make the interviewer understand what actually is overfitting. So these are few the challenges, right? So the first two challenges I already discussed in my last video, guys, and these are the additional 4 other challenges that you can explain to your interviewer whenever they ask this sort of questions. I'm rubbing this portion. Okay, so now we have covered what is machine learning, how it is different from normal traditional softwares, and what are the different types of machine learning, how they are classified, and what are the challenges of machine learning. The last topic that is remained is to understand this mean median mode. So let me do one thing, guys. So I will stop here. So at least I have covered the introduction part of machine learning, where I have explained what is machine learning, what are the different types of machine learning, and what are the challenges we face in machine learning. So in the third tutorial, I will start with basic statistics. Okay, so let me stop here only. I don't want to unnecessarily just increase the length of this video, or else you will get bored. Okay, so thank you, guys. Thanks a lot for watching this, and do subscribe my channel and let me know if any new things you want to understand, want to know from me. I will be happy to help you. Okay, keep learning and keep shining. Thank you.